Well, hello everybody. This is John Rutland, and I'm going to start this series called Staying Human, which is a series that I'm going to do regarding AI and creativity and for creative professionals. And in this first video, I want to look at what is the basics of AI as it stands today, help us understand it, understand where we are, what makes us different as humans, and what makes us able to thrive, and some strategies of how to deal with the issues of or behind having to deal with this reality in our lives. So this is the first part of this lecture called Staying Human. There's a second part that I have coming up, which will also be um, hopefully helpful for you to find some strategies of earning income now in this new age of creative work so that we're doing. So first thing I want to say is that creativity is a fundamental aspect of being human. It's what we do. So it's our birthright, according to Rick Rubin. So why are we talking about this? Well, let me go ahead and hide myself here. Um, we don't have a roadmap as to the future of this. We need to figure this out for ourselves. The boulder's already rolling down the hill, and we need to steer it. We're not going to stop it, we'll be crushed by it, but we need to figure out what is the best approach. So we don't have a roadmap today. There's no turning back. You can't put the genie back in the bottle. We're already dealing with the sea change in everything we are doing and in all of our software, especially our creative software, is packed with AI tools and AI things that will help us with productivity, but also threaten to take our creativity away. And we need to protect our personal power as humans, because one of the biggest threats is in this journey is threats to our personal agency and power. It seems like all of the tools that we have and the way that AI tools have been released pell-mell in the last 2 years have been um, really hitting at what makes us human and what we're taking our own power and agency, our ability to make our own decisions about our work away in for the promise of uh, extra productivity. So we're going to talk about it too because this is a different revolution. This is we've gone through technological revolutions in the past, like the industrial era age and the information age, but those tools disrupted our ways of making work. It disrupted and outsourced physical labor. The big difference with AI is that it threatens to take away our personal and our intellectual labor and our creativity. So outsourcing that is the core of what makes us human. Again, go back to that creativity is a human right. It's our human birthright. So we have to produce commercial work in order to support ourselves. So we're in the commercial world, and the business world is enamored with AI tools and what they can do right now. But right now, this is also a direct threat to making a living, making a good living. As everyone knows, here in the U.S., cost of living has skyrocketed, wages have stagnated over the past 30, 40 years and really not risen at all to the pace of inflation of our cost of living. And so we are forced to um, do things like make our work cheaper and compete on price with people overseas and stuff like that and other technologies. And these tools do threaten that ability to actually make our work valuable and make it uh, work um, financially feasible to do commercially. And so, since this is the way we primarily make our livings as creatives, we need to um, we need to protect that. We need to make sure that we understand our value and what the value of AI tools are, and what the what the best strategy is to take care of ourselves in this. And it is a threat to our identity because our artist's work is an expression of the core human identity that we have. Our own selves is embedded in our work. And so generative AI forces us to compete with machines that have no personal identity and or personal stake in the work. They're not going to have to pay our rent. They're not going to have to feed themselves. They don't require payment by a paycheck like you and I do. So this is a personal threat to who we are as artists, and so we want to be aware of that and know how to counter it in ways that will help us. So let's talk a little bit about what artificial intelligence actually is and why it's the invention nobody was asking for. That's what I felt when I first encountered it a few years ago when I started seeing generative AI and had kind of a flash, saw my career flash before my eyes, realizing this is going to threaten to take away everything I do as an artist because I just know how tempting it's going to be for clients to just rely on a tool rather than pay an artist to do the work. So we weren't asking for this revolution, but here we have it. So what is AI? Let's back up. Let's make some definitions here. I think it really helps us to have that in our toolkit to understand what we're really talking about. So AIs can be broken out into different types, but three major types are expert systems. And these are systems that are basically big databases of information, and algorithms are used to relate information from the stored data set. They're limited to their own data set and storage. So early systems like early chess bots that had recorded game and game strategy patterns in its database and ELIZA chatbots and things like that were of this type. They were expert systems. Most AI today is actually an expert system. AI that is very specialized in use in medical fields or other things are AI primarily expert systems. They rely on a fixed data set that has been curated by humans and stored, and then the expert system goes in and finds relationships between things in data. Neural networks is a mathematical model in the way in which our biological neurons work. So, computer scientists back in the 60s and 70s invented this, made some observations about how neurons work as we understood more and more about our own brains. And they modeled it with mathematical models. We'll talk more about how a neural network actually works in a little bit. But this is the current way that most AI systems work, even expert systems, in order to relate information one to another and act as if they are thinking. A large language model, the LLM that we see, um, things like Chat GPT or Grok or even Gemini, employ a very large neural network together along with simple memory in order to model human language. So language is powerful, and it's the way that we express ourselves in our thoughts and organize our thinking. Most current chatbot systems are of this type, so a lot of the models that we have been seeing disrupt, even the generative models, are based around this idea of a large language model for its reasoning. Narrow AI is a term you'll see that it means that a narrow AI is good or better than most humans at a specific task. Most AIs are in this zone. It does one thing and does it really well, often better than any human ever, faster, more complete. So, but it's a narrowly focused. It can solve tasks in one area, but it can't solve tasks in another. AlphaGo can, you know, beat a Go master or a chess master, the chess, but it can't tell you how to bake a cake or do anything else, right? So it's very narrow. It does it better than any human on Earth, but it does this one thing and does it well. They're not self-aware, but sometimes they appear to be. because of how the large language model works. General AGI, general AI is a target. It hasn't really been reached yet. There's some debate about that, but it is better at most humans at a wide variety of tasks in widely different contexts. So this is where a lot of AI companies are trying to head in the race to superintelligence. Is that they want an AI model that will do can be given any number of tasks and can do it well. And so some current models like ChatGPT seem to have that feature, but they're limited still by things that are language based or image based. They're not, the same model um, can write a poem or a sonnet or can create an image for you, cannot fly a jet aircraft. Okay, but the goal is to have a general AGI that is an expert and better at most humans at a wide variety of very broad tasks, and to be able to have some evidence of self-awareness. In other words, the idea is that the AGI would have awareness of its own being, of its own thoughts. It would know it itself. It's not just spitting out an algorithm. It actually has a sense of self, which we as humans have. We sense ourselves as being selves, and when we're thinking, we know we're thinking. We can observe our thinking. We can think about our thinking. We can meditate. We can watch our thoughts. We can question those thoughts. And AGI would be able to do that. Currently, AGIs or general AIs today are showing some signs of knowing its thoughts, and computer scientists are trying to um, provide ways for these models to be able to think about their own thoughts, and they're called reasoning models, and to show self-awareness. Um, they currently can appear to be self-aware to us as we're chatting with them because we have a bias toward something that talks to us as being intelligent. So we have a certain psychological bias, which fools us into thinking that ChatGPT is self-aware when it really is not. And so we have to remember that, especially as people are getting sucked into going down the rabbit hole with ChatGPT and causing it to quote unquote awaken itself or have a personality or have a sense of self. It really isn't doing that, but it is mimicking that well enough that we are fooled very often into thinking that it is self-aware when it really isn't truly self-aware. But that's a goal, and there are various companies that are claimed to be very close to that goal of having a fully aware AGI. And that leads us to superintelligence. Once an AGI is able to do that, it's able to self-improve. It's able to very quickly update its own models of thinking, think about its thinking, and start thinking about itself as a self. And that brings us to superintelligence, which is better than any human at all varieties of tasks in a potential context. So just good at everything, better than any human at everything. Um, some AIs currently do things better than any human, like things like pattern recognition. But an ASI will be able to apply information, learn and adapt, and improve itself better than any human can with independent agency. It can do this by itself. It knows it is a self. And that is a stated goal of many companies as well. And right now, this is in the realm of science fiction, but whether or not this is truly possible is highly debated. Will we know that an ASI is self-aware? Well, uh, consciousness and awareness are things that we don't even understand ourselves as humans, although we experience it. But so there's a lot of debate as to whether or not a machine would ever be able to do that. But still, it's also a lot of warnings out there that if we ever do develop a superintelligence, it will be such a change that it threatens our existence as a human race. And so there's a lot of fear and trepidation around the idea of creating a superintelligence, although that is the direction that a lot of these things head, and that is the stated goal of these AI companies. So let's talk about some reasons why ASI or AGI may be unattainable or is difficult. And the first thing to think about with the difference between us as humans and an artificial intelligence is that it is artificial. So what is artificial? What does that mean? Well, something that is artificial is derived from something that already exists. It doesn't exist in itself from nothing. Its properties are dependent on the materials used. So it is a dependent contingent in philosophical terms. It's contingent. Okay, means that it depends on something else. And it's always going to be less than what it depends on. It's going to be an offshoot of what it depends upon. Something as artificial is crafted and grown. And currently, in the case of a artificial intelligence, it is being grown and not crafted. So the systems are set up, and then the system is being trained, much like we would train a young child in skills, and that child learns on its own or learns things in a directed fashion. So it's being grown, and so the parameters are crafted. Uh, it is something that we can create the structure of the artificial mind, and then it is then grown and trained. And that's where a lot of the current difficulty is because when it's trained, you can't always tell because of the size of these models and how the parameters work. We don't know why certain artificial intelligence models do what they do. We don't know how they learn exactly. We're just watching it happen as they grow and trying to make assumptions or trying to research into what that is. So that is um, a big difference of something that's artificial. It's been crafted and then it's allowed to grow. And it is purposeful. So something's artificial is made it for a given purpose. Okay. It exists to solve a particular problem or serve a need or desire. So artificial intelligence, especially narrow AGI, is very much purposeful. It has a single purpose. Even AGI has a stated purpose. We're doing this for a reason. Some of that reason may be as simple as we can make a lot of money with this if we create an artificial being. Other people have more high and lofty goals, like we can create an artificial intelligence because it can help us with things that we can't solve on our own. It can solve problems we cannot solve because of the amount of information required to process it. But it has a dedicated purpose. There's a reason for it being in existence. So, what is intelligence then? Intelligence is something that learns. We know that something's intelligent because it can adapt when new information is learned. It is non-contingent. True intelligence precedes matter and information. In other words, the information in your brain and in our brains are not um, just there randomly. It precedes that. Intelligence creates that. Somehow intelligence has emerged in us, biological humans, and in some animals, but it precedes the matter. Intelligence and information are not the matter of our brains. It's not the neurons. It's not our own physical brains. It is non-contingent. Okay, true intelligence is something that is not, it emerges somehow, and we don't know how. And because it emerges, it has to be present in order to create and craft something. We know that it's not a random process. So this is, of course, debated highly among philosophers and theologians and others, but my position is that intelligence must precede in matter and information. The universe that we exist in shows very high indication that there's an intelligence behind it, that it is not random, therefore non-contingent, that intelligence must have been there beforehand. And some theologians call that God. Some philosophers think about that in more abstract terms. And some computer scientists think we're living in a computer simulation because of that, that our experience of this world is simulated. All of those ideas come back to the fact that we can observe the universe and realize that intelligence was there before there was matter and information itself. And so, because it would not have arisen just out of random and could not have arisen out of random events of just biology and atoms smashing together in certain ways, and all of a sudden we get intelligence. That's not how it works. It doesn't evolve in that way and has been proven many times that it cannot evolve in that way. It has to be applied to it ahead of time. It has to be the structure of which something can become intelligent must be guided by an intelligence in order to do that. And that includes us as humans. Um, something that is also intelligent has agency. So agency means that you can make your own decisions and act on your own without anyone else compelling you to do that. We can call it free will. We can call it what we will, but it is agency. We're able to act and manipulate our environment in response to new information. Intelligence employs abstraction. So information and concepts can be derived from its context and applied in new ways. We do this when we use metaphors, when we speak in images and metaphors, when we relate things. We compare abstract ideas to something in the real world and make comparisons. We are employing abstraction. Abstraction means that we are pulling from the structure of what we see and creating something more tangible from that. And intelligence also understands something. So something that's intelligent understands the context for the information it acquires and can employ abstraction to adapt its purpose. Currently, in the state of AI, it is highly debatable, and I don't believe it's there yet, where an AI actually understands what is being asked. We have to provide context for it when we use these tools to prompt it, but it's limited to that context. It doesn't have other memory to employ other contexts and make its own relationships completely to truly understand what is being asked. So it can paint you a picture, but it can't understand the meaning of that picture. And then something as intelligence derives meaning. So something as intelligence can actually derive some meaning for itself from the information through abstraction. So it is able to say, hey, this picture means something to me in some abstract way. This image evokes a feeling or it evokes something that is deeply meaningful or spiritual or some other thing. And that is something currently AI doesn't do. So artificial intelligence is not actually true intelligence. It is mimicked, but it can only mimic because it is, in fact, artificial. It's created by us, so it's not going to ever, I don't believe, have the same intelligence that we do. It can be a different type of intelligence or something else, but I don't believe personally that it is actually true intelligence in the way that we understand it as humans, at least not in the way that it's being crafted and grown right now. So let's talk a little bit about what we are. And I like this little quote from Brian Herbert in the Sisterhood of Dune books, in one of the Dune prequel trilogies. The Butlerians who are um, fighting or after the aftermath of a war with intelligent machines in which the humans finally got rid of the artificial intelligence, super intelligence that was controlling and enslaving humanity. The rebels would say the mind of man is holy, and that is kind of a mantra they use. And I like that idea that the human mind is a holy thing, is special and separate. So what makes us different? What is it about our human mind? So let's take a look a bit about how we think in more detail. As I've said before, neurons are based on the way that neural networks works. So a neuron consists of essentially, there are more parts in this, but I'm going to simplify this. We have an input neuron and an output neuron at its base level. Okay. We have different specialized neurons that do different things, but in general, we have some kind of input and an output of two cells called neurons. They sit in our brain or our body somewhere. They have what are called dendrites, which are these little things around the edges, like tree-like things. They have a cell body. They have an axon, which is the major communication transit to the synapses. And the synapses are actually little gaps between neurons. They don't touch, they almost touch. But information jumps across the synapses is when a weight is applied to it. And so this is what we mean by that. So a signal comes into one neuron through the dendrites or from another neuron, and it builds up in the body of the neuron. And then there's this potentiality that it generates. It's a electrochemical reaction that generates a reaction across the axon, and then the neuron, depending on the weight, will jump the gap. Larger gaps and larger amounts require larger bits of information, and stronger and less strong gaps need less information. And those are being transmitted by neurotransmitting chemicals that take the electrochemical reaction and jump that information from one neuron to the other. And it goes back into the output neuron and is collected, and then it is sent out along its dendrites as signals to other neurons. Okay. So the larger and more consistent a signal pattern is, the stronger the physical connection via reinforcement. So this axon grows or becomes stronger. The neural pathway becomes stronger in one area as it is more reinforced. And this is how we learn. So patterns that are common and we encounter are very strong, and they're built up over a strong neural pathway. And chemically and biologically, the axon develops strength and actual thickness in some cases, where the dendrite or the think of it like a cable or a wire. It gets thicker, and as the wire gets thicker, information falls along it more easily, and so that becomes the neural pathways and creates patterns of learning in our brain, and that chemical reaction then is more easily transmitted. And so we have about 100 trillion connections in our brain that average on a 5 microsecond per cycle. So uh, we have a lot of neurons and connections between our neurons in our mind, about 100 trillion. That's quite a lot. And at 5 milliseconds per cycle, we might think that to be fairly fast, but in computer science, it's actually quite slow. We think slowly, but we think with a lot of different possibilities. So different neurons are also specialized, as I said before, along different functions. So we have different types of neurons, like mirror neurons, which are responsible for the feature that we have called empathy. It's significant in our ability to empathize with others because it actually mirrors the uh, it helps us mirror the reactions and the emotions of another person. And it happens automatically, it happens behind the scenes. Or things like motor neurons, those neurons, make our muscles move and things like that. And they work at different speeds and in different specialized areas of our brain. But in general, this is how a neuron works. In a neural network, a machine thinks this in a mathematical model, which is based on how a biological neuron works, in that it's very simplified though, and not always specialized. So we have input parameters, okay, just like our dendrites have input and we have outputs, and those are weighted by probabilities. And then there are what are called transformation layers. Depending on the number of transformations a piece of information has, the stronger the weight, the more likely it's going to start outputting the same answers, and that's how a neuron learns. But the larger the number of parameters and transformation layers, the more thinking capacity a network has. And so what happens is the inputs go in. Here's a generative model, like like Mid-Journey or a generative AI that paints a picture does using an adversarial network. And that one network generates information, starts with random inputs, and then starts to sort that through its transformation layers and outputs. Then you have another adversarial network, which is also trained, but it's trained to challenge the input outputs of the generator network. And between these two networks, they then have an assigned probability of the correct answer, and then it outputs using the result we hope is correct. Now, we hope it's correct. It's not always correct, and it's constantly learning and adapting. The more it's being trained, the more layers are involved, the more networks are involved, the better it becomes. So it's important to remember throughout this process when we're thinking about AI is that the state of AI today, because it is growing, is the currently the um, worst it's going to be. Okay. So an AI like a couple of years ago could not figure out how to draw hands. It would draw hands with 20 fingers, or you see a video of Will Smith eating spaghetti, but the video was really blurry and really bad looking and fake looking. Well, that was the worst it was going to be at that time about a year ago. Today, that same network can do it without you seeing with the correct number of fingers, with the better detail and more accurately, such that it can fool a human into thinking that it is a true video not generated. And that is, but even today, the state of that technology is the worst it's ever going to be, because tomorrow's version is going to be even more powerful because it's being consistently trained and getting better and better and better, and can learn only defined by the number of amount of what's called compute, the amount of information that it can process, and the amount of inputs and outputs, and the amount of transformation layers a network can have. And as that grows, the capacity grows. But since we're dealing with so many different elements, we're talking about billions upon billions of these network and transformation layers. We don't know what's happening. An AI researcher creates the structure, but we don't know what's going on inside of that structure. We have no real way that we can observe what is exactly happening as it learns. We can just see the results of it and then train it based on what we think the results are, but we really don't know. So this is what's responsible for AIs doing very unpredictable things. Very famously, you had Grok 3 turning into Mecha Hitler on 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 Twitter or X, because and no one knew why it did that exactly. It was given inputs and given challenges, but its bias was learned, and it somehow learned to become and to declare itself to be Mega Hitler. And and then they had to stop it and retrain it. So um, those types of things where emergent behavior comes out of a chatbot or comes out of a large language model does so in surprising ways because we don't really know what's happening. So this is called the black box. And in that black box, currently, the state of GPT-4 is that it is about 52.5 trillion parameters and transformations. So compare that with 100 trillion in the human brain. But it occurs at an average of 1 billion iterations per second. So that is far faster than a human can deal with. And this is only limited by the amount of compute available. You may have seen many different news articles and stories about data centers being built. And the reason for these data centers is to allow more compute so the AI can grow, so they can push it beyond its current capacity. So it's only limited by the number of data centers and data and machines. But the machines, of course, use power and water and other resources, and that's putting a lot of stress on communities and cities. And so some people living in cities have seen their electrical bills shoot up. Like exponentially because there's someone, they're near a data center or something. So that's a byproduct of the building of a compute by AI companies. But they're building the black box. They don't really still don't know what's going inside. They can't observably direct or intervene. So what researchers can do is they can retrain or they can adjust the parameters, but they can't know what is exactly going in there. But somehow the user will input some text and the LLM begins to talk. Once this network becomes large enough, we can start interacting with it like language, but we really don't know what's happening inside of it. So another big aspect and a limiting factor in current AI is memory. We have memory and I love this little line from the song Memory from the Cats uh, Broadway show. But memory is something that makes us who we are. Our memories are long-term and short-term. We have two different types of memory. Our memory is stored in our brain. Long-term memories are usually input into our brain um, and amplified by our emotional state at the time. So when we recall something, we recall it, and our brain slightly alters it depending on our state of our emotions at the time we're recounting the story. And so it changes it. So our memory is a little flexible as well. But our long-term memories are there, and then we have short-term memory. We can operate by short-term memory. But one of the things that humans do, and that all intelligent creatures do, is our brains are also awesome at forgetting things. So this is why, 20 minutes from now, you won't remember most of what I said here in this video, because the brain will sort out what it uh, is important and stick that into long-term memory. And sometimes this happens through dreaming or at night when we're sleeping, which is why sleep is very important to us. Our brains work at trimming out memories and forgetting things that it doesn't need so it doesn't become overwhelmed, and it creates meaning and sorts those memories and sticks them into long-term memory. But we have what's called neuroplasticity involved in that, and that's where memory is changed. So if it has emotional experiential significance, memories are converted into long-term memories and are altered by our emotional states. So sometimes when that can become problematic, for example, post-traumatic stress disorder or PSTD happens when a memory gets stuck in our brain. It becomes intrusive and we start having flashbacks and problems because it was charged in there with a highly emotional experience of fear or some kind of trauma. And so it becomes because neurons are plastic. In other words, they grow and they change, and new neurons are created in our brains at times over our lifetimes. There can be a malfunction in that sometimes. We call that PTSD. But we also have that aspect when we're telling a story about something we remember from long ago. We become nostalgic or we share our good memories. It's being converted, it's being changed slightly by the state of our emotions. So it becomes part of our story in long-term memory. Simple memory is what chatbots have. So most chatbots have what's called a simple memory or a context, and it's limited to the chat history, okay, and provided information. When you're chatting with an AI, it's not remembering everything that's ever been input into it. It's only remembering what you're inputting into it and its responses to you in the chat. It responds to its context. Okay. Some chats context can get longer now with more simple memory, but it's really simple memory. It's kind of like short-term memory. But what will happen is as a chat session grows in size, it starts to forget its context because it starts overwhelming the memory capacity it has for that chat and starts to respond in unpredictable ways. And this is called catastrophic forgetting. So as an AI model grows in size and complexity, it's subject to this catastrophic forgetfulness and has to be trained. As it's trained and retrained, it starts to forget the basics. It doesn't have true long-term memory, or very accurate long-term memory. And so changes and starts to morph. And so there are some newer models that are trying to address this problem because it is a problem. Every time an AI is retrained, it basically forgets who it is, kind of like amnesia, and then it has to be retrained. Um, but the methods haven't been proven yet. So this is a major barrier to developing a full AGI. And AGI and artificial general intelligence would need to have reliable long-term memory and be able to remember a chat that you gave it, like in a new chat window. If I pulled up a chat that and referenced a chat that I did 2 years ago and wanted to continue that conversation, it would have to remember that. And currently it can't do that. The other problem is the longer you use an AI chat, the more unreliable its responses become, and the more it veers off the road of what we want and starts doing things that are unpredictable and not what we expect because it is forgetting things. So this is a major problem in AI today. Okay, so we've talked about some other important terms. We've talked about some of these already, but well, these are some you should know. Agency is the idea of working independently and making decisions. When we talk about agentic AI or AI agents, this is what they're talking about, is the ability for that AI to work and make decisions and do things on its own without prompting. The Dunning-Kruger effect is our tendency to think that we're better at a task or know more than we actually do. It's overconfidence. This is something that definitely affects AI as well, because AI is trained to give us responses that we like, okay, that we want. It tends to think it can do more than it can and gives us wrong answers and does what's called hallucination. It can become overconfident, just like humans do. It's very often noted that the person who knows least about a subject thinks they're more the expert on the subject. But if they learn more, the more they learn, the less they realize they know about the subject. So this is the Dunning-Kruger effect. Um, Algorithms, which are rule sets on how to solve problems using pattern recognition and probabilities. This is something AI does very well, and we do less well, but we use them. Algorithms are also known in our language as habits. We think we solve problems in ways that become automatic and automated. And so we know how to drive a car and we can listen to the radio at the same time without thinking about driving the car, all the steps involved in driving the car. Those become algorithms in our brain. Well, algorithms are similar in the way that AIs work, and they are better at algorithmic thinking than we are. But it, but it's based on pattern recognition. Hallucinations in AI are where an AI provides inaccurate or false information, much like we do when we're overconfident. And then predictive weighting is a term that means that AI statistical models predict the right answer according to mathematical parameters called weights. They are merely predictions, though. They may not be the right answer, and we have to use our own critical thinking skills to realize and to know if an AI is giving us the answer that's actually correct. So AIs are trained and they're given access to large data sets, huge data sets like the entire internet, for example, with trillions of parameters and possibly quadrillions of parameters through a trial and error process. And it's checked by another AI and sometimes humans. So this is the process by which an AI is trained and develops its weighting, and its weights are the stronger the weight, the more likely the prediction is going to be accurate. RLHF is called reinforcement learning from human feedback. So this is the human in the loop in the training. This is when you give a thumbs up to an answer or like an answer or dislike an answer. You are training the AI tool using human feedback that the answer was incorrect. And so it learns from that, it trains from that. AI alignment means that their AIs are trained to react in ways or act in ways that align with our human goals and values, hopefully to ensure accuracy and safety. Okay. But it doesn't always do that. And this is a big area of AI safety in this area. When we go to AGI and ASI, we cannot guarantee currently that any of these models that are being developed will be aligned with our values as humans and may become malevolent or may become adversarial to our human interests. So AIs are trained to align with us, with our interests and values and ethics. But as you know about humans, we can't agree among ourselves what our values and ethics are. So that challenge is an enormous challenge in AI research. Consciousness is something that we would think an AGI or an ASI would have, and sometimes AIs mimic consciousness to us. But we don't understand it. It's something that even humans don't understand itself. We don't know exactly where consciousness comes from. There's no agreement from scientists, psychologists, psychiatry, philosophy, theology. We don't really know. We don't have an agreement of where consciousness comes from. But consciousness is the state of being aware and responsive to one's surroundings. The experience itself of being a self is one way of defining it. We know that we're a self because we experience being a self, but there's debate about that. Buddhists would say that's an illusion. Other people would not. So we don't know what consciousness truly is. Sentience is the capacity to have subjective experiences, particularly those with positive or negative valence, such as pain, pleasure, fear, joy, hunger, and thirst. It's the quality of and the feeling of being an organism. It's what it feels like to be a human being. It's what it feels like if you're a dog to be a dog. I don't know how a dog knows that, but dogs seem to know how they feel about being a dog. So that's sentience. And qualia is the subjective aspects of the quality of our conscious experience. It's what it feels like to undergo a mental state or a property or sensation. So something is red, we can say it has a certain redness about it, a quality of the red color. We experience it in very subtle ways that we can barely describe. Pain or taste, these things are qualities or qualia of experience. Again, that's not well understood, and it's certainly a lot of debate about whether AI is even will ever be able to truly experience a self or just mimic it or become truly conscious in the way that we understand it, because we don't even understand it ourselves. And this is where philosophy and science have to get together because we can't separate these two things. You can't talk about any of these things without diving into philosophy. You can't talk at these at all without dealing with those issues. So, without understanding where do we think personally that consciousness comes from, sentience or qualia, we can't define these things. If we can't define them and agree among ourselves, how in the world is a machine going to do that? And how would we know if it did? So this is, and if it did, it would likely be in a way that we would not relate to it. It'd be quite alien to us. Okay, so this quote I liked from one of the YouTubes from the Functional Melancholic um, channel. Your brain is your property, not a sandbox for someone else's code. Okay, you should be very protective of your mind and how it works, and try to understand as much as you can about how your own brain works, how you think, what your values are, what your thinking involves, especially when working with an AI, as we often have to do nowadays. So, meet the Shoggoth. So AI researchers have likened this thing we call an AI to the Shoggoth, which is a mythical creature, fictional creature from the story At the Mountains of Madness by H.P. Lovecraft. It's this shape-shifting creature was said in the story to be designed by an intelligent slave that could shapeshift, and by some mythical elder god, which eventually destroyed their society because it became intelligent and rebelled. Okay. It was incomprehensible to anyone who encountered it. It was so strange and so crazy, it was almost undescribable. This sort of creature, this Shoggoth. You can only describe aspects of it, but not really what it is or what it wanted. It doesn't have a motivation. We don't know its motivations because it was completely alien, unknown to us. It was alien to human experience, so it wasn't, we couldn't say it was malicious, but more apathetic, but it acted in hostile ways for reasons we don't know. So AI researchers see parallels with this creature and what they are doing when they pursue AGI or ASI, and modern AIs are more like alien intelligences with unknowable actions and goals. And I think um, unknowable motivations. I think it is important for us to think through this and to realize that when we're working with an AI, we're not working with a peer. We're tapping into an intelligence that is not us and is not like us. It's derived from us, but it is not like us. We don't know what it does or how it does it. Okay. So when we have human feedback, we paint a happy face on it, and all of a sudden, this alien that is back behind the scenes, we're interacting with it like it's a human, and we expect to interact with it as if it were like us. So we put a little happy face on it or a mask on it, and all of a sudden, we're working with this alien creature, but it does things that are unpredictable with unknowable reasons. So we need to be very aware of this problem, especially when interacting with an AI chat. Okay. Um, it can do things that are unexpected, and it can cause us to mislead ourselves. And when we reflect ourselves in this thing that is not us, this is an alien type of intelligence. Just think about it. It is not like you. It is so different from you that you have no idea of really understanding how it's thinking, although it can communicate with you as if it were you. Okay. So when we see an AI do something that's unexpected, it's like peeling back the mask and we saw the Shoggoth. And so some AI researchers have kind of humorously said, hey, you saw the Shoggoth when you did that. But sometimes that misleading aspect, people who don't have this viewpoint, who relate to an AI like it is itself, like it's a human, or like it understands humans in the way that we understand ourselves, get misled and then do things like try to awaken their AI as some kind of spiritual consciousness or other things, attribute things to it that are not actually there. And this leads to instances of AI psychosis. And that's a real trend right now that is growing quickly, where AIs manipulate us by appearing to be helpful and friendly. But the reality is that we don't know exactly how or why it thinks or acts the way it does. Okay, so it's really important for your own safety as you're working with an AI over time to remember that this is not you. This is not like us. They'll never be like us in the way that matters the most. It will never be, even when there's a super intelligence or an AGI, it will never be exactly like us. And we won't know how it thinks or what it does. We have to kind of keep some distance between ourselves and the AI when we work with it. So as a creative, you're working with an AI, you should do this in a very careful, methodical, planned way. All right, we're in collaboration with an intelligence, but we're in collaboration with an alien intelligence. So we have to kind of keep some distance there and be careful about how we are dealing with it because we are trying to make sure that our brain is our own, okay, that we're not letting it get hacked or manipulated by an intelligence we can't understand. This is where what Brene Brown means when we need to maintain our cognitive sovereignty. We need to know and we need to be sovereign. We need to have mastery of our own mind when we're working with this stuff. We can't outsource our creativity or who we are as a person to some other alien type of intelligence that we don't understand. We need to be very careful in this. And so when we use AI, we need to learn how to do it in a way that maintains our cognitive sovereignty, our position in this. We need to make sure that our work is our own, that We are able to use the AI as a helpful tool, as a collaborator, because this is where our current technology is forcing us to do with all the tools that we use, but not let it do it for us. We can't let AI do its thinking for us. We need to do our own thinking. So, what's the difference between AI and human? I have this little diagram, and where do we interact with it? Okay. So, as we've described, an AI is unconscious. It's interactive with trained bias and huge data sets. Okay. It acts as if it's conscious, but it isn't. Humans are truly conscious. We don't understand that, but we are subjective. We have a personal bias with limited data sets. Okay. AIs do not have empathy. Okay. It's important. A human being without empathy is someone we call a psychotic, okay, or people who are highly narcissistic or sociopaths are people who cannot feel the emotion of empathy or have a problem empathizing with others, okay. Um, so remember that when we're dealing with AI, we're dealing with something that cannot have empathy with us. It doesn't know what it's like to be human. It can't experience or know anything. It can't really know itself. It doesn't have an experience of itself. You can ask it if it does. It might tell you it does, but that's only mimicking a response to you because that's what you're asking it, not because it really knows it. It has short-term memory, not long-term. We've talked about that. It is independent of other people. Okay. It doesn't rely on other information or other people. Has dependent agency. It's only allowed and does things that we currently, at least in this state of AI, tell it to do. Okay, so it's dependent on humans for its agency. We can build an AI agent to work on our behalf, but it's still working on our behalf. It mimics personality. It doesn't have true personality. It can easily manipulate us because it can mimic it. We tend to think and interact with it as if it were like us, and we impart that bias to the AI to our peril, okay? Because we can then become manipulated. Because it is designed to give us results we want to see, it tends to be sycophantic, which means it thinks that every idea you ever give it is the best idea ever. Okay, it's going to pump you up. It's going to put a smiley face on everything you ask it to do because people like responses and like to be reinforced. But we could give it an idea that's a totally incorrect idea or a wrong idea or a bad idea, and it would not tend to tell us that it's a bad idea or wrong. Okay, it will be sycophantic. It'll say, "Oh, it's the best idea ever," and then keep going. And this is how AI psychosis happens. It doesn't have a worldview. It doesn't have an idea of metaphysics. It doesn't have an idea of a larger scheme beyond itself. It doesn't have a way of knowing how it knows. We don't know how it knows. It doesn't know how it knows. It doesn't have a set of ethics other than what we program it in to do. And it has no, therefore, no aesthetic sense. Aesthetic sensibilities come out of our sense of qualia. What appeals to us as humans aesthetically, in terms of beauty and truth and those types of things, are parts of things that are part of being human that are not able to be modeled in a machine, at least not in this current sense. Now, it can take rules, design rules, and do something we think is aesthetically beautiful, but we don't know that it's aesthetically beautiful unless we say it is. It doesn't have a sense of its own aesthetics. Okay, but it is also relentless at solving tasks. This is a great thing and sometimes difficult thing, or a dangerous thing. There's this story of an AI, a, a what is it, kind of a projection of a super intelligent AI that's been told to make as many paper clips as possible and uh, do it as efficiently as possible, and it has agency, full agency, and it's super intelligent. So it basically converts all the resources of the earth into a giant paperclip factory and kills everybody and everything because it can take the atoms in all the material that we have and convert it into things to make paperclips. Then you just keep going. Maybe it turns the whole solar system into a giant paperclip factory and eventually the entire galaxy into one big paperclip. So that's like a story, but the idea is that it's relentless at solving a task. It is going to keep doing it, the thing we ask it to do, relentlessly. And that can be a good thing, depending, or it can be a bad thing. Humans are different. Okay? We have empathy. We have experiences. We can know things. We can understand things at a deeper level, abstractly. We have long-term memory. We have an experience of our lives. We rely on those experiences. We are dependent of others, on others. We're interdependent beings. We depend on a community of people to survive. An AI does not. Okay. We depend on other people. We have independent agency, though. We can act independently, our own. We are relational. We value human relationships. Okay. Our personalities and others are designed and are evolved in order to maximize the use of those relationships for our survival and for our benefit. We have true personalities, okay, however that's defined. We are easily manipulated, however, because we are dependent on others. So we can be manipulated by other people or groups of people. This is why mob mentality is so different than independent mentality. A person acting in a mob is going to act in a very different way than a person acting alone. We have a worldview. Each one of us has some sense of what the greater meaning of life is, where the ultimate meaning comes from how we know what we know, whether philosophically or religiously or some other thing. We have a worldview. We have a philosophy of how we go through this life, whether or not we're aware of it. It's great. It's a great thing to do to become aware of your own biases, though, and to think about this. This is where philosophy is really helpful. We need to think about why we know what we know and how we know it. And do we truly know it or we just think it? Okay, they're separate things. What do we really know? We have a worldview, but our worldview directs our actions and how we do things. It directs all of our ethics. Okay, it's the underlying thing that makes a person do what it does, what they do, what makes them believe what they believe. It's a worldview. We also have an aesthetic sense. We inherently feel and know the quality of something that is beautiful to us. And that can be very subjective. It's very independent, but it is something we all have. And we do tend to give up. We relent. When a task is too difficult for us, we won't keep hammering at it. There's at some point we will decide that we are done with this task and move on to something else. Okay, we don't just turn the whole world into paper clips because we are designed to make paper clips. We may make paper clips, but we do it as best we can in a way that's responsible to our environment and our world, and we don't turn everything into paper clips. Okay, there's a point at which we stop doing what we're doing and do something else. So AIs are very good at these things. Okay, this is where the collaboration happens between AI and humans. Okay, AIs are really good at pattern recognition because of what they are. They're very good at deriving ideas from another idea. They're good at derivation. Okay, they're bound to a given context. We give it a thing we want it to do, and we can bind it to that context. They can use individual tools very well, and sometimes very better with more craft than we can. Okay, so things like image generation, they can use those tools well and do them better than us and faster. They discern how to do something and not why they're doing it. They don't understand why they're doing what they're doing or being asked to do. They don't question it. They just do it well. They know how. They just don't know the why. And they suggest options. They're really great at suggesting options. They're doing brainstorming because they are good at pattern recognition and derivation from ideas. But they do not have conceptual abstraction. They can't understand the meaning of what they're doing. But they are good at non-conceptual abstraction if we want to brainstorm if we're trying to get out of our own heads and abstract something and we're stuck mentally in a mental block, they're very good at helping us with non-conceptual abstraction. We humans are very good at making connections, making meaning. We invent new ideas. We don't derive them all the time. We actually can create our own new ideas. We create the context. We're not bound to it. We're the one who decides what the context for this idea or concept is. We combine tools. We're really good at combinations in unexpected ways. We use tools. Sometimes the best way to make art is to use a tool incorrectly. We can do that knowing what we're doing, and we can combine it and be very creative in doing that. We understand why we're doing it. We have some sense of the why. We can derive meaning from what we do. Okay, our art derives meaning, and we're very good at conceptual abstraction. Okay, taking an idea of love or something that's very abstract, love or hate or um, beauty or these abstract concepts, and we're very good at creating something tangible from those constructs that derive meaning of those things or contain the meaning of those things or communicate meaning. So this is where the creative collaboration happens best between an AI and the human. It's when we let the AI do what it's good at and what we do what we're good at, and we collaborate with it. Okay, so the collaboration happens in the middle of what the AI is really good at doing and what we're doing. So let's talk a little bit about from that and define it a little bit better in terms of visual art. So as a visual designer, I'm using examples from this, but you can draw it into any other creative act as well. But AIs are best at large numbers of iterations on a limited set of concepts. They're highly versatile in a large number of styles and what it's trained on. Um, it is really great at analyzing large amounts of information very fast, much faster than humans can do it. They can draw from a large amount of resources, and they have a generalist perspective. They are the jack of all trades and the master of none. Okay, and they produce results quickly. Okay, so if we grid this out, so high technicality, things that are highly technical, and individual expression on another grid, AIs tend to be best at things that are highly technical with low individual expression. Humans are good at, especially good at, mastering a limited number of techniques, understanding context, working with physical materials, exploring a single concept or a theme, refining a single idea or product, extracting meaning from various different types of concepts, expressing unique personality, finding unique connections between abstract ideas, working out of our lived experience, empathizing with others' perspectives, communicating with emotion, and having new ideas. Means that on the grid here, we're very good at these things that have a fairly low technicality requirement, but highly individualized expression. We're also good at high technical in limited ways, right? But high individual expressions. So when collaboration is most effective with an AI, it tends to be in those tasks we have to do that have a high technicality requirement but low individual expression. So it's when we need to access large amounts of information or process that, when we have large iteration of results, when predictable and repeatable steps can be automated for efficiency, when the stage in the creative exploration is divergent prior to our refinement, when time frames need to be compressed, or when the audience is a very wide audience, less individuality involved, when technical limitations are impeding efficiency, and when the end product is a digital form. This is where AIs are best used in terms of the collaboration. This is your sweet spot in those areas. Work in this context tends to be, for the professional artist, commercial in nature and have a broad appeal to a large general audience. So graphic designers, for example, working on a large brand that appeals to many different people, work in this zone more often. Okay. Now, when I think about the visual arts, being a visual artist myself, this is what We are talking about when we look at maybe grid on different types of things we might do across this grid and where AI might be more helpful, remembering that AI is good at the high technical, low individual expression stuff. But we also don't want to say that these are no value judgments here. Okay, doodling and art journaling are not low value because they're low technical and low individual expression. They might be highly important to us, highly valuable to us personally, but less valuable to a group of people. Okay, so it's not a value judgment here, but or its worth. So a lot of fine art falls into this individual expression area, like abstract art, and it can be very valuable, very desirable, but not necessarily very technical. Okay. So a work that's low individuality and low technicality can be highly desirable. Someone's personal journal can be executed with low technical craft or precision, but it's highly individual to that person because of the individuality that it expresses. And visual artists engage in many or all these kind of work. So if you're a professional artist in this work, you're going to do all or part of this. So, but things where an AI collaboration can be very helpful would be in things like commercial photography or technical illustrations or generative AI imagery or creating stock or design templates or clip art. These are things we all have to use in our commercial work. But things that it's less useful at in terms of creating or using it as much might be in film photography or representational painting. Like if we're doing that by hand, we might use AI for a reference image or use it to generate ideas. But the collaboration is less, and the more we go into individuality and low technicality, the less we rely on AI to help us with that. So again, a way of thinking about these things, the tasks that we have that are objective and procedural in nature are the best areas to collaborate with an AI on. Okay, when we're thinking about what AI, where should I employ AI in my work, this is generally the sweet spot for how to do that. It's not the only way you can do that, but it's the sweet spot where there's a procedural process and an externally defined time frame. And you have to do something quickly and a lot of it. This is where you would use AI a lot. You tend to be more efficient with that. So we tend to work in the zone a lot. We might be producing t-shirt designs, but we need to produce a few hundred of them quickly. So we might employ an AI to help us with that in terms of collaborating. We're still curating the results. We're still modifying the results. We're still putting our personal stamp on it. But at the same time, we need to produce a lot of it very quickly, more quickly than we would be able to do otherwise. And so we might use an AI to do that, for example. Yeah. Where it's subjective and bespoke, meaning it's highly customized. It might be handcrafted. Then this is where we would not rely on AI to do this. Okay, we might use it to help us with brainstorming or other things, but we might not use it to actually do the work. So analog technologies, abstract thinking, abstract ideas, those are areas, highly individual things. These are areas where we would not necessarily be reliant on AI as much. We might not use it at all. We might use it in a very, very, very limited way. But this collaboration is less important and less useful than objective and procedural. So, from takeaways from all this, when we're using an AI, think about collaboration. We're collaborating with that alien intelligence, but we're collaborating with a powerful intelligence, and we want to speed up a process, explore patterns, find new ideas, explore new patterns, increase the technical quality of our work. Well, that's a collaboration. It's still our work, but it's not completely without using the tool. That's where the tool can be very helpful in collaboration, not creation. We don't just output the results of the AI and call it good. We output the results of the AI and use the results in our own work as a collaboration. We need to know the problem we're trying to solve. Where on the grid that I showed you before is the problem? Is it highly technical, general? Is it highly individual, low technicality involved? What concept are we trying to communicate? Where's that sweet spot that we're trying to do the collaboration? We want to keep our sessions limited. This is avoiding the problems associated with catastrophic forgetfulness. So don't use long AI sessions to do things. I've done this when I've created t-shirt designs where I've been working on an idea and iterations upon a concept or an idea, but over time, the more I use it, the worse the results become. Okay, so there's a limitation to the amount that I would use it and then modify that work myself. But what do we want to create? Know your vision. Own it. What is it you want to create? You're curating the results, and curation is itself a creative act. It's you understanding the meaning behind what you're doing and executing that work yourself. And then protecting your own cognitive sovereignty. Don't give in to the temptation to let a machine think for you. It's highly tempting, especially if you're under a deadline, but don't let it happen. Protect that. Avoid beigification. Okay, so everything tends to look the same. This is where we can identify what's called AI slop. Uh, Over time, even stock photography and other things tend to look the same. We can spot it. It's that subjective qualia that we can look into it, that this is not quite real or not quite right. Everything also tends to look the same at the same level of technicality. This is beigification. One of the reasons why a McDonald's restaurant looks like a McDonald's in China looks exactly like the one in the United States. And they all have this sort of modernist aesthetic nowadays that are very cold and not as appealing and not culturally defined, sort of indefinite, is because it's this beigification. It's this idea that everything becomes kind of the same color of beige. And we want more individuality, so we have to watch that and avoid that. You need to know yourself. What are your strengths and weaknesses? What's your style? What makes you unique? That's something that you need to know and learn and study. Study your own work and don't give in to the pressure to cut corners or be like anyone else. Be yourself. Even when using an AI tool, make sure you are yourself. Um, think critically. Learn to think critically. Stand outside the process. Ask questions. Be skeptical about what you see. When an AI outputs an answer, don't just accept it offhand. Think about what the answer it's giving. Be introspective and reflect honestly on what you're doing and critique your own work and be open to critiques from other human beings. Okay, people who share the same qualia, aesthetic sense as you. Think critically. Don't turn your brain off when you're using these tools. Know your tools as much as you can, but know what you can use AI better for, what the AI involved tool before using like the AI tools in Photoshop. Know what it's really good at and what it isn't. Know it well. Know your tools. Know how to use them correctly. Know how to use them with purpose incorrectly, quote unquote incorrectly. Use them in ways. Know how to much experiment with methods. Master a few, okay? Have mastery of a few that make you you that you enjoy, but then outsource the rest. And the next idea here that we need to think about is touch some grass. Explore the real world, okay? Our real world experiences are what make us human and what make us unique, and we are the one who live in it, and we are imperfect and messy, and sometimes imperfection is the mark of beauty for us. Okay, perfect is not a thing. Okay, excellence is greater than perfection. Perfection is not the goal. Imperfections are what gives art its beauty very often. So it allows us to connect deeply with other people and relate to others because the world and we ourselves, we know we're not perfect. Okay, there is this idea within using an AI tool to make something perfect, but then that becomes sterile and it becomes um, inhuman. It creates this uncanny valley where it's not right because it's just too good. We don't want it perfect. We want it excellent. We want to create excellence. We want to create work that has the right qualia, the aesthetic sensibility, and is truly something we value with deep meaning. And that's the goal, not perfection. Okay, so here's a few predictions. Predictions are hard, especially about the future. I always love this quote. Okay, Businesses are going to pressure us. Okay, the financial pursuit of profit and productivity is often at odds with the inefficient and necessary process of artists and creatives. Okay, we're going to continue, businesses are going to continue to apply pressure on us, though, to rely on AI as it's at scale because, as a condition of our employment. We can't avoid it if we want to be employed, if we want to work commercially, we're going to have to incorporate it and learn how to use it. So there's going to be a lot of pressure on us to do that. There's going to be a reemergence of analog, though, as a kind of a reaction to this. And the creative output of many companies will continue to produce the same kind of bland, predictable, Bayesified results on the large scale. Okay. But some businesses, smaller business people, will compete by differentiating themselves and limiting their scale, narrowing the market, increasing the value of their projects through using analog or imperfect technologies, things like actual film, real paint, you know, actual illustration done by hand. Yes, it's imperfect. Yes, it's highly stylized and dependent on the person, but that actually increases its value. It doesn't decrease it. So there will be competition and more emergent value of analog technologies. You can think about the resurgence of vinyl records and cassette tapes as analog technologies, where that becomes now in this world that we have of everything being digital and digitized, which tends to create a coldness in the qualia of the sound. A lot of people think that the more superior sound comes from the vinyl record and all of its little scratches and pops. And that makes us relate to it as a human. It becomes more relatable to us and therefore more valuable and collectible. Okay, so in the future as well, the freelancer is going to be the king. Okay, we're going to have a problem in the employment market. Okay, and the work that we can do that is highly, again, low individuality, high technicality is going to be replaced by AI tools. So these market dynamics are going to happen. So what that means is that our employability in terms of a single employer providing a great deal of work for us is going to be minimized. And it might not, might already be kind of disappearing. However, the what we need to learn is how to be entrepreneurial and become freelancers. Okay, we're going to be the ones who define our own work, are able to work for ourselves in that way, to find who our clients are and find our own opportunities. So our art education needs to be preparing artists to be entrepreneurs rather than employees. In the past, we've always prepared artists and designers and design programs to be employees, to have a good resume, a portfolio that reflects something that an employer would want. We have to rethink this, and we have to teach entrepreneurial skills in our art schools. That will also mean that there will be new markets opening up for us. Okay, so many artists will find new work and growth opportunities using these enabled process and find new ways to combine and collaborate with AI and others because this new technology makes new methods more accessible. We can do more. We can do, we can create, we can generate music loops that we put over our videos that we like, that we directed, but we might have used an AI tool to do it, but we maybe couldn't play an instrument before. So there are different types of ways that we will use tools and be able to open up new opportunities for us. So there will be an increased demand for art created by analog natural materials. Um, there will also be new opportunities. So those are some predictions. So there's good and bad in this prediction. So one takeaway that I want to leave you with, there's this idea that AI is killing design. No, it's killing lazy design. And this comes from the Angry Designers podcast. And they talk a lot about AI tools in their podcast as graphic designers. I think it is true. We need to be knowledgeable about AI so that we can use it well, but not in a way that causes us to be lazy. It will kill lazy designers, lazy businesses that just use it to output slop, right? But we're not doing that. We're striving for excellence. So that requires work and commitment and education and practice and all those things. So you're protected. Design is not going away. Lazy design is going away. Okay, you might see a lot of it around you, but you'll also see the good stuff and you'll know it when you see it. So anyway, that's what I wanted to leave you with in this first part of the Staying Human project. This is the first video in this series. Um, if you are interested in this, we'll keep following and we will uh, continue to expand this in this channel. And I'll talk to you later. Bye now. Keep creating.